All right, this is for Wednesday for KAP. We started the class with a minor ticket, so if you were absent today, talk to your teacher about making that up. You shouldn't be taking that on your own. Please find a time to work with them to work on that ticket since you'll need to be on Zoom. All right, hopping into the quick lesson today though. First we're gonna look at this warm up. So we got like 5 graphs or tables, and we're gonna first see, we haven't really talked about how to tell if a graph is proportional, but we do know if things are multiplicative and we can write the equation. We've been practicing that. So we're gonna start there. Okay, hopefully you remember from like 2 weeks ago, a quick, easy way to tell if something is multiplicative is literally if it goes through the origin, straight line through the origin. So I can go through the table 0, 0, yes, it's multiplicative. Okay, that one, nope, doesn't go through. Again, same thing, no, it doesn't go through. Yes, and yes. Okay, so if it's multiplicative, that means it's just a quick one-step equation to get from y to x. It's just multiplying. So those equations for those multiplicative should come pretty quick since we've been practicing that. So to go from 1 to 3, 2 to 6, 3 to 9, I hopefully see that's y equals 3x, just times 3. Okay, those could be additive or one of the 2 steps, but let's move on to this next one. 2, okay, so 2 times 5 is 10, so that's too little. 2 times 6 is too much. Same thing, times 5 would be too little, times 6. Let's try in the middle. Let's do 2 times 5.5. Yeah, that's probably gonna work. So that's 10, 11, add the decimal. Yep. Okay, so that's y equals 5.5x. Yeah, that'll work. And then the last one, it's times 2, but it's ending up negative. So I am starting with a positive, ending up with a negative. So that means my multiplier is a negative number. Negative 2. Let's see if that works. Negative. Yep. Y equals negative 2x. Okay, for these other ones, again, it could be additive or it could be one of those 2-steppers. So we want to like figure out a number, and if I can add the same thing every time, it's additive. So like starting here, I could add 2. Let's see if that works. Yep. Okay, so that means it's just an additive relationship. They're taking y, x plus 2. For the next one, if I do plus 4, oh, okay, so that's not working. The plus 4 isn't working every single time. So C must be one of those 2-step equations that we practice this week quite a bit. And we need to find like the rate of change and the y-intercept. Cool thing about it, it has the y-intercept. Remember, wherever x is 0, that y value is going to be my y-intercept. So I already know that's going to be like y equals something x plus 3. Okay, so we just need to find the multiplier, the rate of change. As we've been practicing to do that, we find the change in y. That's plus 2, plus 1. Yeah, plus 1 each time. Okay, remember it's the change in y over the change in x. Change in y was a positive 2 over the change in x was 1. That simplifies down to 2. And again, my y-intercept, which of course we're going to check, is right there. It's 3. But of course, I'm going to pick a point. I'm going to plug in 4. 2 times 4 is 8. 8 plus 3 is 11. So that works out. All right. So when it comes to proportional, we haven't talked about what that looks like. So we're going to actually do the lesson. It's a quick little run through, and then we're going to come back to see what relationships we see. Okay, so the notes page is like literally a front and back, and I'm going to go through it pretty quickly. Okay, so the big vocab word for today is the constant of proportionality. Proportions, we've spent the last couple of months talking about how proportional proportional things like have the same scale factor, they simplify to the same thing, unit rates are the same, they're equivalent rates, all those stuff. They're like, it's just different ways of writing the same ratio. Okay, so if it's staying constant and it's proportional. So we're going to see how we can apply that to a graph. Okay, so we can say that 2 quantities are proportional. proportional if they have a constant ratio or unit rate, like I just said. For two quantities where the ratio is not constant, we would say they are non-proportional. So that's like when we simplified two things and they didn't have the same unit rate, they are not proportional. Another way we can determine if two quantities are proportional is to graph them on the coordinate plane. And this is actually really cool because you can just look for two things, that's it, and you can tell if it's proportional or not. So if the graph of the two quantities is linear, okay, that means it makes a straight line and passes through the, what do you think? The origin. Then the two quantities are proportional. It literally has to be a straight line through the origin, bam, done. And if you think about that, this also means that the two quantities have a what kind of relationship? It's a line that goes through the origin. That's a multiplicative. Okay, so there of course is a value for like if they are proportional. The measurement of how two quantities are proportional is called the constant of proportionality. Okay, this is like when you simplify it down, it is the constant rate, and we use the letter K to show it, and it's a ratio of Y to X. So putting that into a fraction form, K is the ratio of Y to X. Now take note, I'm not finding the change in Y or the change in X. I'm just going to take a point from the graph, from the table, just a point, and I'm going to put it as a ratio and simplify it down. Okay, that ratio, when it's in simplest form, whatever it simplifies to, that is again your multiplier for your multiplicative relationship. So that means it's going to be kx. And this again makes sense and it ties into that multiplicative relationship. There's nothing added onto it, just straight multiplication. Okay, this is just a little side note. The x is always going to be the denominator. You might have noticed that with, again, this situation right here and when we were finding the rate of change. The y is always in the denominator because we're looking more at the dependent value. Y is our dependent, and we're trying to see how this changes. We control like the change in the x. We want to see how that affects. Okay, this depends on this. So we want to see what kind of effect that has. That's why it's up top. Because we always measure the dependent value based on the independent. So the independent is always the base. That's just a little y. Why is it y over x? Okay, so let's practice finding the constant of proportionality. We're going to start with tables. This one takes the most work. The rest of them are actually pretty quick. Again, that ratio of y to x. Okay, and to make sure that it's constant, you want to do this for all ordered pairs. Okay, you have to check with every single ordered pair, but there is an exception. We do not want to do this when x is equal to 0, because like think of it, if you put 0 over 0, it's not a thing. It literally cannot be put in the calculator. Okay, so you'll do it for all points except for the x equals 0. If they are all simplified to the same, that means they have a constant of proportionality. Okay, and again, to find that, it's y over x. So I'll do one and then you do two. I don't look at when x is equal to 0. I do it for all other points. So k, the constant of proportionality, is equal to y over x. Again, I just pick a point. I'm going to put 3 over 1. That simplifies to 3. I want to do this for all points. So 6 over 2, that simplifies to 3. 9 over 3, again, I'm putting y over x. That's 3. And bam, 3 again. So because it always simplified to the same thing, that is proportional, and k is going to be 3. That is my multiplier. Okay, so pause. You do the next two, get your answers written down, and then play when you're ready to check. Okay, again, I don't look at x equals 0. I'm going to put k equals y over x. Negative 3 over 1, signs are different, negative wins it, 3. Negative 6 over 2, signs are different, negative wins it, 3. And if I keep doing that, it's going to stay proportional, where k equals negative 3. Okay, last one. Don't look at x equals 0. I'm going to do it for all of others. Again, k is equal to y over x. 4 over 1 simplifies down to 4. Very good. 5 over 2 simplifies down to, that's not 4. That's going to be, it comes out 2 times with a half left over. I don't even need to keep going. I already know right then and there it is going to be non-proportional. So there is none. There is no constant proportionality because it doesn't work. So when it is non-proportional, there is no constant of proportionality. I'm abbreviating so I don't have to write it all out. Okay? So a really cool thing, let me pause and pull this up real quick. Okay, so the really nice thing is that this is on the star chart, the constant of proportionality. Again, this is a 7th grade skill, so this is on the 7th grade star chart. If you ever forget, oh, I don't remember how to find constant of proportionality, I remember the word, okay? It's on that star chart right here. It says k is equal to y over x. Right next to our other best friend, the y equals mx plus b. Remember, m was talking about rate of change, k is talking about constant proportionality. There is a difference, and maybe you've already started noticing some things, but we'll talk about it some more later. Okay, going back to the slides. Okay, so that was for tables. The next 2 parts are going to be pretty quick. We're going to do it from a graph and from an equation. So how to find a constant of proportionality from a graph. Again, there was 2 things just by looking. We checked that the graph is linear and it passes through the origin. It has to have both of those for it to have a constant of proportionality. If it checks both of those things, you find any point and you put y over x for any ordered pair. Again, the exception to that rule, we never really want to use origin. Never use origin, because that's not going to, it's going to throw things off. Okay, so just looking if it's proportional or not. Is it linear? Does it cross through the origin? Okay, straight line, check. Goes through the origin, check. It is proportional. Okay, goes through the origin, check, but that's a spaghetti noodle. That is not a straight line. It is not linear, so it is not proportional. Okay, that's straight as a noodle, an uncooked noodle, but doesn't go through the origin. So let me write that. So not linear. That's why this one was not proportional. This is not proportional because it's not through origin. Okay. Last one, is it a straight line? Check. Does it go through the origin? Check. It is proportional. Okay. Thinking about my multiplier, oh, do I remember what causes things to go up versus down? Maybe you do, maybe you don't. Let's find out if we can see if we can find something. Okay, so you, to find k, you just put any ordered pair that's not the origin and you put y over x. So I'm going to do this point right here. That ordered pair would be over 1 up to x and y. So I'm going to put y over x. I'm going to put 2 over 1. That simplifies down to 2. Over here, again, I'm going to avoid the origin. Let's do this point out here just to change things up. I went over -3 and I went up 3. If I put y over x, +3 over -3, remember this is just fancy division. Signs are different. Negative wins it. 3 divided by 3 is 1. Okay, so maybe you remember the thing that causes the slope to go downwards is it's a negative multiplier. Okay, cool. That's literally all you have to do for graphs. Linear, origin, bam, done. Okay, not the easiest, but the next easiest, a little bit harder, is equations. Just looking at an equation. for a proportional equation, it must be in the form of, what did we say on that front page? It must be in the form of y equals kx because it's a multiplicative relationship. Okay, so we are literally just looking for multiplicative equations. It must be in the form of y equals kx because it's multiplicative. Okay, remember if it has anything added onto it and any extra fluff or anything like that, that means it's not multiplicative. That means it's a two-step. That means it's additive. It is not going to be proportional. Okay, and if so, k is just going to be that, like, if I look at this equation, I already see that this is multiplicative. This number right here is k because I replaced k with 10. That number, when I put the number before the variable, some teachers might have mentioned it last week. I only mentioned it like once. It is called the coefficient. Coefficient. Okay, so that's just whenever there's like, whenever we write it as multiplication with a number and a variable, the number is called the coefficient. It is 10. Okay, so again, is it multiplicative? Yep. The coefficient, or the constant of proportionality, is 3.2. I see some fancy. They trying to go fancy on me. So this one is not proportional because of that second step. And then if you want to pause and try those next three out on your own, you can. Play when you're ready. Proportional, 5/3. And no, there's just a lot going on. Okay, and then lastly, yes, -9. Okay, so let's look. We need to sort of do a deep dive into how constant rate of change and constant of proportionality are different. In the constant rate of change, what we were doing the last 2 days, we took a table and we were always finding the change of things. We found the change in y to the change in x. Okay, and we found that rate of change in all different types of equations. We found them in additive, we found them in multiplicative, we found them in two-step equations. Okay, so we can have a rate of change in any linear equation. Any linear equation. Okay, so let's pause. What I mean by that is, like, up here, we definitely could find the rate of change of things like this. And that's either an additive relationship or a two-step equation. Okay, but we said it didn't have a constant of proportionality because it wasn't multiplicative. Constant of proportionality measures the ratio not of change in y and change in x, it's just the value of y to x. Okay, this was not in all linear equations, it was only in multiplicative. Multiplicative. Okay, so we're going to practice like determining that. We're going to practice that over the next few days. It is important to know that there is a difference. Rate of change is for any linear equation, constant of proportionality just for multiplicative. So going back to this, determining if it's proportional or not. This is multiplicative, yes, it's proportional. This is additive, so therefore no. And we can go back and look. If I put 5/3, 5/3, that's the same as like 1 2/3. If I put 8/6, I can take that out once, and I would have, 2/6 left, which is the same as 1 1/3. Okay? So if it's additive, it is not proportional. If it's two-step, if I put 5/1, that's 5. If I put 7/2, not quite, that would be 3.5, 3.5. So again, not proportional, not multiplicative. Multiplicative, yes. Multiplicative, yes. Okay. Tomorrow we'll do a lot of practice. For today, that is all.